Okay, for this function, our first step is to identify the vertical asymptote. So for this one, we have x equals positive 4. Keep in mind that it's always based on the denominator. You just set it equal to 0 and you solve. From there, we then have the horizontal asymptote at y equals positive 3. From there, now that we have the VA and the HA, we can now write down the domain and range. The domain is based on the vertical asymptote, so it's given to us by negative infinity, comma, positive 4, not including it, union. Then from positive 4, comma, to positive infinity. Then we also have the inequality notation, which is given to us by x is less than 4 or x is greater than 4. We also have the set notation, which is given to us by all x's, except x cannot be equal to 4. Otherwise, it would make it undefined. For the range, we have the following inequality notation. We have it as y is less than 3 or y is greater than 3. We also have the interval notation from negative infinity to positive 3, union from positive 3 to positive infinity. We also have the set notation, which is given to us by all y's, in which y cannot be equal to 3. Otherwise, it will make it undefined. And for the transformation, we're going to indicate that the f of x was translated right 4 units, comma, and up 3 units. From there, we are then going to graph the rational function. We have a vertical asymptote at x equals positive 4. So we are sketching a vertical dashed line going through x equals 4, just like this. We're going to put an arrow, label it x equals 4. And then we have a horizontal asymptote at y equals 3. So we have a flat horizontal line like this at y equals 3. From there, we are then going to do a rough sketch. It doesn't have to look perfect. Now, we know that if we're dealing with a positive rational function, then the hyperbolas will be located in the first quadrant like this. Make it a nice smooth curve. And we have another parabola in the third quadrant like this. Again, it doesn't have to be perfect, but we want to get as close as we can to the asymptotes. Okay, so now let's move on to question number 2. For number 2, my vertical asymptote is going to be located at x is equal to negative 1. My horizontal asymptote will be located at y equals 3. My domain will be set as x is less than negative 1 or x is greater than negative 1. I have the interval notation from negative infinity, comma, to negative 1. Union, and then we have it from negative 1, comma, to positive infinity. We then have the set notation, which is going to be for all x's in which x cannot be equal to negative 1. Otherwise, it will make it undefined. For the range, we have the inequality notation, y is less than 3 or y is greater than 3. We also have the interval notation from negative infinity to positive 3. Union, and from positive 3 to positive infinity. We have the set notation to be the set of all y values in which y cannot be equal to 3. And for the transformation, we're going to write down that f of x was translated left 1 unit, comma, and up 3 units. Okay, now we're going to sketch the rational function. We have a vertical asymptote at x equals, at x equals negative 1. So let's go ahead and sketch that out. X equals negative 1 is right here. This is the vertical dashed line. And we have a horizontal asymptote at y equals 3. Let's go ahead and sketch that out. Okay, from there, we notice that this is a positive rational function, so hence we have our hyperbolas located in quadrant number 1. So we're going to get it as close as we can to that asymptote, and then, whoops, like this. And then we're going to put arrows on each end. Same thing, we're going to get as close as we can to those asymptotes and then all of a sudden turn to the other side. They don't have to be perfect as long as we have the rough idea of how they look like. That should be good enough. Okay, all right, moving on to the next question. We have f of x equals 1 over x minus 5 minus 6. So this is going to give us a vertical asymptote at x is equal to positive 5. We have a horizontal asymptote at y is equal to negative 6. For the domain, we have the following inequality notation: x is less than 5 or x is greater than 5. We also have the the interval notation from negative infinity, comma, to positive 5, union from positive 5, comma, to positive infinity. We have the set notation for all x's in which x cannot be equal to 5. Okay, and for the range, we have it as y is less than negative 6 or y is greater than negative 6. We have the interval notation from negative infinity, comma, to negative 6, union from negative 6, comma, to positive infinity. We also have the set notation for all y's in which y cannot be equal to negative 6. For the transformation, we're going to say that f of x was translated right 5 units, and then down 6 units, okay? From there, we are then going to sketch the rough sketch of the graph. We have a vertical asymptote at x equals 5, so let's go ahead and make that vertical dashed line going through x equals 5. Then we have a horizontal asymptote at y equals negative 6, so this is y equals negative 6. Okay, and then we're going to create our hyperbolas. And again, we want to get as close as we can to that, to those asymptotes. So we have it at quadrant number 1 right here. We do a curve going to that side. And then we have another hyperbola all the way here down. That's going to be our second hyperbola in the third quadrant. Okay, all right, let's move on. For the next one, we have the following. We have a vertical asymptote at x is equal to negative 3. We have a horizontal asymptote at y equals negative 5. For the domain, we're going to say the following inequality notations. We have x is less than negative 3 or x is greater than negative 3. We have the interval notation from negative infinity, comma, to negative 3, not including it, union from negative 3 to positive infinity. We also have the set notation, which is going to be for all x's in which x cannot be equal to negative 3. Whoops. Okay, and then for the range, we have the following. For the inequality notation, we have y is less than negative 3 or y is greater than negative 3. We also have the interval notation from negative infinity, comma, to positive infinity, union from negative my apologies, that is not correct. All right, then from negative infinity to negative 5, comma, oh, not comma, not including it, union from negative 5 to positive infinity. We also have the set notation, which is going to be the set of all y values in which y cannot be equal to negative 5. Okay, and for the transformation, we're going to write down the following. Now, keep in mind that for this one, we have a 7 on the numerator, which represents a vertical stretch. So we're going to say what? We're going to say vertically stretched by 7, comma, translated left 3 units, and then down 5 units. Okay, from there, we are then going to graph this rational function. So on the, we see that we have a vertical asymptote at x equals negative 3. So we are sketching a vertical dashed line. Let me just double check this. Yes, we're sketching a vertical dashed line across x equals negative 3 right here. Okay, and we have a horizontal asymptote at y equals -5. Okay, and then we're sketching a hyperbola in quadrant number 1. This is a positive rational function, so we should have a hyperbola in quadrant 1 and in quadrant number 3 from the new vertical and horizontal asymptotes. Okay, let's go ahead and move on to the next one. For the next one, notice that we have a negative symbol in the front. So this is going to be a reflection across the x-axis. So that means that the hyperbolas will be located in quadrants 2 and 4. So for this one, we have a vertical asymptote located at x is equal to -8. We have a horizontal asymptote located at y is equal to 0. There's no k value here, so it's a 0. And then for the inequality notation, we have x is less than -8 or x is greater than -8. We have the interval notation, which is given to us by -infinity, comma, to -8, not including it, union from -8, comma, to +infinity. We have the set notation, which is going to be for all x's in which x cannot be equal to -8. For the range, we have the inequality notation, y is less than 0 or y is greater than 0. And we have the interval notation from -infinity, comma, to 0, not including it, union from 0 to +infinity. We have the set notation, which is going to be the set of all y values in which y cannot be equal to 0. For the transformation, we're going to indicate what? We're going to indicate that it's reflected across the x-axis, comma, and we're going to say what else? We're going to say that it's translated left 8 units. Okay. And from there, let's go ahead and graph our rational function. So right here, we notice that we have a vertical asymptote at x equals -8, which is going to be located right here. This is x equals -8. Okay, and then we have a horizontal asymptote at y equals 0. So we have that flat horizontal line right there. Okay, and from there, we notice that this is a negative rational function. We have a reflection across the x-axis, so we should have our hyperbolas in quadrant number 2, like this, and quadrant number 4, like this. Okay, all right, and from there, we're going to then move on to the next question. This one also has a reflection across the x-axis. So let's go ahead and identify the key attributes. We have x is equal to 0 for the vertical asymptote. For the horizontal asymptote, we have at y equals -2. We have the inequality notation for the domain, which is going to be x is less than 0 or x is greater than 0. We have the interval notation from -infinity, comma, to 0, not including 0, from 0 to +infinity. We have the set notation for all x's in which x cannot be equal to 0. For the range, we have y is less than -2 or y is greater than -2. We have the interval notation from -infinity, comma, to -2, not including it, union from -2, comma, to +infinity. We have the set notation for all y's in which y cannot be equal to -2. For the transformation, we're going to indicate that this is a reflection across the x-axis, comma, and we're going to indicate that this is shifted down by 2 units, or comma, translated down 2 units. Okay, now we're going to go ahead and graph this rational function. We have a vertical asymptote at x equals 0. So this is x equals 0 right here. And we have a horizontal asymptote at y equals -2. So this is y equals -2 right there. Okay, so now when we graph this, keep in mind this is because of the reflection across the x-axis, because of the negative situation that we have, it's going to be in the second quadrant, the hyperbolas, second quadrant, and the fourth quadrant, like this. Okay. All right, so now from there, let's go ahead and move on to the next part. For this part, it involves long division. Keep in mind that if you ever have a variable on the numerator, you have to do long division to get into the graphing format, okay? So what do? Let's do the long division, okay? So I'm not gonna do the key attributes for this part right here. I hope that by now you should have seen enough examples that you can do this by yourself. But I will do the conversion for you with the long division. So let's focus on the first one. We have 2x minus 7 divided by the x minus 4. From there, we ask ourselves, what do I multiply to the first term to get to the second term? Well, it's going to be a whole number of 2. From there, we then multiply this 2 to the x, which will give me 2x. Multiply the 2 to the negative 4, that will give me negative 8. Then I will wrap these terms in parentheses and put a negative symbol. And from there, I can distribute the negative symbol or just keep it mentally in my head, your choice. I recommend that you change it with a different color pen, okay? So this, instead of a positive 2x, we now have a negative 2x. I'm doing this in green. Instead of a negative 8, we now have a positive 8. So now when I put this together, the two x's cancel out. And I have what? Negative 7 plus 8, which will leave me with a positive 1. So my new rational function will be in the form of y equals the remainder 1 divided by the x minus 4, and then plus 2, which is what we were able to divide by. And this is going to be my new rational function that I can easily identify the key attributes as well as graph. For the second one, we have to divide the negative 3x plus 2 by x plus 3. So we ask ourselves, what do we multiply to the 1x to the first term to get to negative 3x? Well, in this case scenario, I multiply by negative 3x. Then we multiply this negative 3x to both terms outside. So we have negative 3 times x, which will give us negative 3x. Negative 3 times positive 3, which will give us positive 9. We then wrap this in parentheses and put a negative symbol in the front, and we distribute it. Okay, so the negative 3x right here will turn into a positive 3x. The positive 9 will turn into a negative 9. So now when I combine it, the 3x's cancel out, right? One is negative, the other one's positive. And we end up with what? 2 minus 9. 2 minus 9 will end up giving us negative 7. From there, I will then write down y equals negative 7 divided by the x plus 3. And then we have minus 3 outside. And that's going to be my new rational function right there. Okay, for the next one, we have 2x minus 10. We're going to go ahead and divide it by x plus 3. So we ask ourselves, what do I multiply to that first term to get to the first term 2x? Well, I multiply it by 2. So we multiply 2 times x, that will give us 2x. 2 times 3, which will give us positive 6. We then wrap this in parentheses and we subtract. From there, we can distribute the negative symbol. So this will now turn into negative 2x. This will turn into a negative 6. And we combine like terms. The 2x's cancel out. We're left with negative 10 minus 6, which will give you negative 16. And if I put this together, this will give me what? Y equals negative 16 divided by the x plus 3. And then finally, we put a plus 2 right there. Okay, that's going to be my graphical rational format. Okay, so now let's move on to the next part, okay? Now, for these questions right here, converting to the graphical rational format, you have seen multiple examples just now, and let's go from there. Let's move on to this part. This is what you will see on the RA as well. It says the time, as well as the test for the multiple choice, it says the time it takes to build a fence varies inversely. So let's go ahead and box that key vocab word, inversely, with the number of workers. If it takes 3 workers, 12 hours to finish the job, how long would it take 9 workers? Write the equation and solve. So for this one, First, we identify the k value, the constant of probability. We know that if we're dealing with the inverse function, it is given to us by k is equal to x times y. So in this case, keep in mind that the first variable that they represent will always be the x value, and the second, it would be the y value and then followed by the x value. So in this case, this time is going to be my y value, and the number of workers is going to be my x value. So that's my w right there. So if I put this together, I have what? It takes 3 workers, right? So that's going to be my 3 for x times 12, right? And that's going to give me what? 36. So that's my constant of probability. From there, I know that the equation for the inverse function is given to me by y is equal to k over x. And from there, we substitute it in. So this will now turn into y is equal to 36 over x. And now they're asking me how long would it take for 9 workers to complete this job. So x represents the number of workers, so hence we substitute it in, and we get y is equal to 36 divided by 9, which is going to leave us with positive 6. Okay? Not positive 6, positive 4. Okay? All right? And that's going to represent the number of hours that it will take. Okay? So it's going to take 4 hours for the time. Okay? So this is my equation, and this is the solution of how long it will take. Okay, from there, it says for the next one, it says the amount of money earned on a paycheck varies directly. So for this one, we've boxed the vocab word directly with the number of hours worked. So again, same idea. The first one is always my y. The second one is always my x. So from there, we know that if it says varies directly, we know that the constant probability is obtained by having k equals y over x, just like this. Okay, so for this one, we have what? The money earned, $210 divided by 14, which is the number of hours. And if we type that into our calculator, let's see, 210 divided by 14, that's going to leave us with 15 for the constant of probability. Now, we know that the equation for the direct variation is given to us by y equals k times x. So we have what? We have y equals 15x. So that's my equation. And they're asking me how much will they earn after 35 hours. So from there, I use that equation that I just formed, and I have y equals 15 times 35. So 15 times 35, that will give me y equals $525, okay? So that's how much they will earn after 35 hours, okay?